Hello Maths fans, back with another Maths Watch Help video this time. This is for an assignment and the question for the assignment is question 45. If you've done that assignment, if you haven't, then this might just be revision for circle theorems. You do need to look through your circle theorems and have them in front of you to understand which one to use. Okay, if you haven't got that, then you're going to struggle with this. And then hopefully after a while you'll memorise them and that shouldn't be a problem. But you need to remember to be able to quote them word for word. Okay, so that's what I'm going to be doing in these questions. So if you haven't done that yet, make sure you learn your circle theorems, then come back to this. Okay, question 45 from the assignment, or this is also on clip 183. One of the questions on clip 183. I don't know which one it is at the moment, but you could find that out yourself. Okay, so you look at this. BE is a diameter of the circle, which means O must be the centre. You've got to read this question carefully. ABC is a tangent to the circle. Okay, so we've got to find ABD. So walking around the angle then, A to B to D, which means we're after this angle here. That is ABD, that angle there. So what do we notice? We've got a tangent. If that's diameter, that must mean that OB is a radius, which means OBA equals 90 degrees, and that's angle between tangent and radius equals 90 degrees. Now look, you notice I've quoted it almost word for word there. I'm not trying to make my own version of that. So if the whole of that angle has to be 90 degrees, what is ABD? Well, ABD therefore must be equal to 90 minus 24, which gives us, what's that, 66 degrees. Okay, now I can write that onto my diagram. That's always a good idea when you're doing angle questions. Part B, that was part A. Part B, find DEB. DEB. Well, DEB, the first thing I notice is it's in a triangle here. Okay, into this triangle. So DEB is this angle here. D to E to B, it has to be this angle here. Okay, so what we've got is a triangle. I know that's a diameter. And one of the circle theorems is that angle in a semicircle is a right angle. So in other words, this angle here is a right angle. That's a special version of an angle at the centre, 180 degrees, is equal to twice the angle at the circumference. So we can say that EDB equals 90 degrees. You can angle at the centre is twice the angle at the circumference, or you can write angle in a semicircle equals 90 degrees. And because that's 90 degrees, we've got a triangle now. That means, so therefore, I don't know if you're familiar with this symbol here, therefore, the little triangle of dots, therefore DEB must be equal to 180 subtract 90 subtract 24, which is also 66 degrees. Now, the sharp-eyed amongst you may have noticed that's 66 degrees. Hold on, is that always true? Well, actually, this is a way of showing the alternate segment theorem. Okay, the angle between a tangent and a chord is equal to the angle in the alternate segment. So that chord splits that circle. If I show you a chord, any chord will split the circle into two segments. So what we're saying is an angle between a tangent and a chord. There's my chord. There's my tangent. Oops, not spelled that too well. Is equal to the angle in the alternate segment. So from these 2 points now, instead of moving into this segment here, I'll go to the alternate segment. That's the angle I would get. It has to bounce off the circumference. Okay, so if you have put alternate segment theorem straight away for B, well done, well spotted. Okay, but you can prove it this way as well. Okay, I hope that helps, and I'll see you next time.